Hi, I'm Anna Hoffman, and I'm a data and applied scientist slash program manager on the Azure Data team. And today I'm also joined by Bob Ward, a principal architect on the Azure Data team. And today we're going to be talking about SQL Server to Azure SQL performance and availability. And we're really excited to share this topic with you. This is actually something Bob and myself have been working on for quite some time, materials related to this. Bob, do you want to share a little bit of the background of why we're doing talks like this before we get started?
Yeah, thanks, Anna. It's great to be with you here today. Our journey started back even last year talking about Azure SQL, comparing to SQL Server, looking at all the different options for Azure SQL, and studying, deploy, and configure. But the meat and potatoes of SQL Server is security, performance, and availability. I'm excited today that you're here to talk about availability and dive into that. And I'll be going into performance and diving in those capabilities with Azure SQL.
Awesome. Well, let's get right into it. Now, today we're going to start by covering an Azure SQL overview just so we're all kind of on the same footing. Then we're going to go into availability, and I'll be taking you all through that. And then I'm going to pass it over to Bob, who's going to cover performance, and finally we'll take questions and we'll also provide some more information. Most of the demos we do today you'll actually be able to do for free on your own time, so lots of exciting stuff to share at the end, so you're not going to want to miss it. We hope you stick around until the end. So before we get into kind of availability, I wanted to start by talking about what is it when we talk about Azure SQL. Now, on the very left, as we go from left to right, what you're going to see is at each level, you're going to get one more layer of abstraction. So one more thing that you don't have to worry about, but also that means one more thing you don't necessarily have full control over. So the first is SQL Server on Azure Virtual Machine. This is just SQL Server on a virtual machine, so you manage the exact version of SQL Server and Windows or Linux that you have, and we kind of provide that infrastructure, so you still are responsible and have control over the OS and the SQL Server, and we call this infrastructure as a service. Now, if we say, I don't really care about the OS, but I do want access to the SQL Server and a lot of those instance scoped features, that's where Azure SQL Managed Instance comes in. And this is really just a managed SQL Server, but you're still going to get most of the surface area that you get with SQL Server. This is also versionless, and this is one of our Platform as a Service or PaaS offerings. Finally, we have Azure SQL Database, and this is, you say, I don't even want to worry about the server. I just want a database, and I want to start building new intelligent applications leveraging new technologies like serverless, automatic tuning, and other things like hyperscale. So that's also a platform as a service. So you can kind of see the spectrum. And today, what we're going to focus on is the things as they relate to Azure SQL Managed Instance and Azure SQL Database. All right, let's get right into it and talk about availability. Now, we're going to talk about this for availability and performance, but we really wanted to talk about the capabilities first and then the tasks that are associated with that. So we're going to talk about things like backup restore, HADR, availability zones, which maybe is something you haven't heard about. And we'll kind of dive into each of these, and then we'll guide you through some of the tasks like choosing what is going to be best for your scenario. Now, I did want to call out, you get a lot as well as transactional replication is supported in Azure SQL Managed Instance. And Azure SQL Database, in addition, can serve as a push subscriber from SQL Server on-prem and Azure VM or an Azure SQL Managed Instance. So those are a few things that didn't quite fit anywhere, so I wanted to make sure I threw them in at the beginning or else I might forget. So let's start with backup and restore. This is very commonly people say, okay, what happens to my backups when I move to Azure SQL Database or Azure SQL Managed Instance? So what you have to remember is we do a full database backup once a week. We do log backups every 5 to 10 minutes and differential backups every 12 hours. Now those backup files are stored on Azure Storage with RAGRS replicated, which means they're read access geo-redundant storage. So this means that your backups are automatically also stored in a paired region to your region. So for example, if you deploy in East US, it's also deployed to a paired region. And we do have some things in the works so that depending which service tier, you can actually switch this to locally redundant storage if you have some sort of data sovereignty requirements for that. Now we also do backup integrity checks. So basically what this means is on an ongoing basis, the Azure SQL Database Engineering team is automatically going to test the restore of a database backup in your logical servers or database pools. Now, when you have to do something like a point-in-time restore, which you're probably already very familiar with, we're going to also do a DVCC checkdb before we do that. Now, one thing to remember about point-in-time restore, which is different from SQL Server, is that you actually have to restore to a new database. So you can't restore onto an existing database in Azure SQL. And this just means, we're trying to help you, really. We say restore to a new database name, make sure it's where you want to be, and then you can change the name of the old version now to change the name of the new version so that you don't have to change any connection strings. We also have capabilities like long-term retention. If our 7 to 35 days isn't long enough for you, you can get up to 10 years of backups with long-term retention. And this is even going to include a deleted database. Now, with the RAGRS, what this means is in the case that a whole region goes down, so let's say something crazy happens, the whole East US goes down, because you have backups in a paired region, so like West US in this example, you can do a geo restore and you don't even have to configure anything to get this. So that's very interesting. Now, additionally, I wanted to call out that you can do a copy only backup restore with managed instance. All right, so now we talked about backup restore. What we're going to do next is we're going to walk through each of the main service tiers in the vCore model and talk about how they work, especially from an availability perspective. Now, the first one we're going to talk about is general purpose. And as the name suggests, this is really meant for most business workloads, and this is where most of our customers live. So how does it kind of work? So what happens is it behaves kind of like a failover cluster instance. What we have on the left, you see an application, then you see a control ring with several gateways, and then you see your primary replica. Now, you can set up different connection policies to either go to the gateway every time, which is known as proxy, or to go to the gateway first and then go straight to the database every time, which is redirect. So that's kind of what that is showing behind the scenes. I'm not going to get too much into it. But then on this primary replica, what you have is you have Tempdb. And then your data and log files are actually stored in LRS, or locally redundant Azure Premium Storage. And like I mentioned, your backups are going to be in Azure Standard Storage, which is geo-redundant. Now, sometimes, maybe it's you, maybe it's the Azure infrastructure, sometimes referred to as Azure Service Fabric, there's something that's up and we need to fail you over in that scenario. Now, in this scenario with general purpose, this behaves kind of like a failover cluster instance in the sense that we have to look for a node with spare capacity, fail you over, and then we take care of all the connectivity redirection. So that's kind of the general purpose service tier. Now, if we switch and we think about business critical, which as the name might suggest, this is really meant for your low latency required, mission critical, potentially you need some read scale workloads. And with that, there is a cost associated. So this would be more expensive than the general purpose tier. But what we're going to do is we're actually going to deploy an always on availability group behind the scenes. And in addition to that, on each of your replicas, really you're pointing to the primary here, on top of having Tempdb right there, you're also going to have the data and log files. So this is different from general purpose, which has the data and log files on locally redundant storage. Now, a few things to keep in mind, your backups are still in RAGRS unless you set something else up, which you can do for certain deployment options. And one thing to be aware of is that at least one of the secondaries must sync for a commit. So just something to be aware of. And in the case that Service Fabric or you decide you need to fail over, it's going to be very similar to an always-on availability group, and it's going to be really fast because all we have to do is redirect you to one of those secondary replicas and do the connectivity redirection built in, and then we can get you back up to running while we spin up your fourth replica. One of the other great things about the service tier is you can use one of those secondary replicas for read-only workloads. So you get a little bit of read scale. Now, I talk about this a lot, and maybe you've seen this demo before, but I like to share this demo because it really shows off the power of PaaS. So what you have to remember when I show this is that I didn't deploy anything special. All I did is I deployed a general purpose database and a business critical database, and we're able to get really fast failovers in both situations, but you'll see how they're much faster in business critical. So let's take a look. Okay, so there's a lot going on here, so just give me a moment to explain what you're seeing on your screen. So in the top, I have Azure Data Studio, and I'm running two notebooks, two PowerShell notebooks. I mean, you guys know I love notebooks, but these are PowerShell notebooks, which I'm using to basically use Azure PowerShell commands. On the right side is connected basically to a business critical database, and on the left side is connected to a general purpose database. Now on the bottom, I have two more PowerShell windows. This bottom right one is also connected to the business critical database, and this right one is connected to the general purpose database. So what I'm going to do is I'm basically going to run these two workloads, and this one. And what you'll see is we're getting the same result. So we're doing the same query. We're using OStress to do this, to hit both workloads, and basically just query to see if the database is available. Now what I'm going to do is I'm going to kick off a failover on the business critical. So remember, business critical on the right, general purpose on the left. I'm going to kick off a failover on both, and I want you to observe what happens. Okay, here we go. So what you're going to see is pretty soon after being clicked, the databases become unavailable. But what you see with business critical is that we're really just redirecting you to a secondary. So this can happen really, really fast. Sometimes this happens in like 2 seconds, but it can take as long as 6 seconds. But at the end of the day, it's very, very fast. And general purpose is also very fast. It usually happens in less than 30 seconds, but I really think this is just a great example of how you're going to get this built-in availability by just deploying. Because remember, I didn't do anything except deploy these databases and these service tiers. Okay, so we talked about general purpose and business critical. And now we're going to talk very briefly about hyperscale, because there's a lot of stuff today, and I know there are other sessions on hyperscale. I definitely encourage you to go check them out, because it's very interesting how we've basically re-architected SQL Server to be cloud native with cloud scale. So similar to the other tiers, you're going to see that you have a primary, and then depending on which tier we're referring to, some optional secondaries that are available. And these two should say secondary. Now what's going to happen is, I'm just going to click through this to keep it quick, but basically you're going to get redundant log and data through Azure storage. That's what you're seeing. And we're able to do this really quickly and really efficiently due to the use of snapshots, which you're seeing down at the bottom. Now, similar to the other service tiers, if Service Fabric decides that it needs to fail you over, the distance or time it's going to take to do that is going to depend on how many replicas that you deploy. Now, hyperscale is very interesting because you can get 0 to 4 additional secondary replicas, and all of those replicas can be used for read scale. So this is very interesting, but as you might think, if you choose 0 replicas, when you have to do a failover, it's going to behave similar to a failover cluster instance or the general purpose service tier, and it might take a little bit longer because you don't have like a hot replica ready. Whereas if you have 1 or more readable replicas in hyperscale, we can make this failover happen much faster. Now, one thing that's also really interesting about this, and the last thing I'll call out, is really that the log service, you can kind of see it was kind of pulled out and it feeds the replicas. And those transactions can complete when the log service hardens to that landing zone. So this is kind of interesting in that the consumption of changes by the secondaries isn't required for you to have a commit. So that's something interesting. And also with all of these new innovations here, again, there's just not enough time for me to talk about it today. But with all of these innovations, we've really changed the size of data operations, the time it takes to do that. So one example is if you scale, you can scale up and down in constant time. It's no longer a size of data operation. So this can relate to your availability as well. Okay, so we talked about the service tiers. We talked about their different availability architectures. General purpose is like that of failover cluster instance. Business critical is like an always-on availability group. And hyperscale is its whole other new thing of it, full of innovation. And you can see some of my comparisons there around IOPS, which is I/O per second. You're going to get the best, most likely, with business critical. Business critical also supports in-memory, whereas the other service tiers do not. So that's something to consider when you're thinking about which model you want to move to. And now we're going to switch gears a little bit and talk about how you can get even higher availability. And this is going to be specific today to the business critical service tier. So with business critical, you have this option to enable a zone redundant configuration. So you might be asking, what does that mean? Sounds very complicated. Well, for you and for customers, it's not complicated. You can actually switch this on and off with one PowerShell command or a nice little button in the Azure portal. But what does it do? So typically, your database is going to be deployed in some data center in a region. Now with availability zones, what we can do is we can spread that availability group across multiple data centers in a region. So you see that kind of on the screen here. And basically what that means is if a whole data center goes down, you still have copies in other availability zones in your region. So you can kind of get up and running much faster. Now, again, like you don't have to do any configuration here. They just do this for you. And if you enable a zone redundant configuration, sometimes called a multi-AZ deployment, because we have all these terms we love, you're going to get a service level agreement, which is very, very high. I think you've probably heard me say this before, but a service level agreement or SLA of 99.995% is possible with the business critical or premium tier and DTU model. And that's really high. If you think about that, and we did the math a while back, that works out to less than 26 minutes per year of downtime, which is pretty incredible. So this is the industry highest SLA, including an RPO and RTO objective if you enable some other things as well. But this is really awesome, and this is kind of a way you can go further and kind of see what you're actually getting from the tier that you deploy. And one other thing to notice, kind of like what I explained, is that you're going to get a higher SLA with one replica or two replicas in hyperscale because we can fail you over faster because you have something ready. Now you might be saying, okay, how can I go a little bit further? And there are options for that, especially when we talk about globally redundant or geo-available type of applications. There are two main options you can consider with Azure SQL Database and Managed Instance, and those are geo-replication and auto failover groups. Now, one thing to call out is while auto failover groups are available in both Azure SQL Database and Azure SQL Managed Instance, geo-replication today is currently only available in Azure SQL Database. So I kind of put this chart together, and I really like this chart because it gives you an idea of kind of what to use when. You know, if you need that automatic failover, then you're not going to get that with geo-replication, so you should use auto failover groups, as the name suggests. Also, if you don't want to have to update a connection string, again, you want to stay available as much as you can. You don't want the downtime, so you just want the connection strings to stay the same. Auto failover group gives you basically a failover group to connect to as opposed to a specific logical server. Again, if you wanted a bunch of replicas in one region, geo-replication is the only way to do that. And if you want multiple replicas, geo-replication is also the only way to do that today. But you're going to be able to use those replicas for some capacity level of read scale as well. So you're going to get that from both. So that's just a very brief comparison between the two. But I hope it helps you kind of demystify what the differences between them are. Now, we can't talk about availability without talking about the database availability and consistency. And there's just a few things I wanted to call out here. We'll share information so you can dive deeper into these things. Accelerated database recovery. We've been talking about this for a while, but this is really important for Azure SQL Database and Managed Instance. This is on by default, and you cannot disable it. And the reason is because we use it to make sure we meet our SLAs. Now, when we think about consistency, there are multiple copies of your data and your backup, so that helps. There are some things you can do. We talked about doing DBCC check DB. There are some things that we do, like checksum is on by default. We do data integrity monitoring. We do backup restore integrity checks, which I talked about earlier, and some more things that you see that are here. Now, one of the great beauties of all this availability consistency things is this is something that maybe used to cause you stress or headaches or concerns, but with Azure SQL Database and Azure SQL Managed Instance, really like Azure and Microsoft is taking on a lot of the responsibility so you don't have to worry about it. Now, as we kind of think about all the different choices we have seen, what you're going to have to do now is kind of decide on a case-by-case basis what makes sense, what makes the most sense for your application. So this is going to be like determining your backup restores type of strategy. Do you need long-term backups? Because you will have to pay the associated storage costs with them. Or are you good with 7 days? Or that sort of thing. You also need to decide if having an RTO or RPO SLA is important to you, in which case that has certain implications around business critical and the way you configure your deployment. It's always important to review the SLA just so you know what you're signing up for and making sure you're getting the SLA that meets your needs. We talked about how you can read scale, whether it's with business critical, whether it's with hyperscale, or with some of our geo-replication and auto failover group solutions. You're going to have to decide which is best for your scenario, which makes the most sense. If you do need that 99.995% of availability, then you also need to consider availability zones. So we talked about a bunch of these things. The one thing we haven't touched on a ton yet is your application ready? So, we talked a lot about your database availability, but at the end of the day, if your application isn't holding to the same level of availability as your database, then, it doesn't matter so much. So, making sure that, your application is co-located with your database, that you have the right networking set up to make it talk easily. One thing that's really important when you move to Azure is actually having that retry logic implemented in your applications. And this is so important because like you have, potentially there's some sort of failover like we saw in the demo, you want your application to go back up and running as soon as that failover occurs. You don't want to be in a broken state. So making sure you have retry logic is a big thing when you start moving towards Azure Platform as a Service offerings. Now, just to wrap this up before I pass it over to Bob, we talked about a lot of stuff. I really hope this was useful. I hope you learned a lot. And at the end, I will share a bunch of resources how you can get hands-on and do the demo I showed you earlier, as well as lots of other demos. And with that, I think I'll stop rambling and I'll pass it over to you, Bob.
Thanks, Anna. Great job on diving into the availability capabilities in Azure SQL. Let's talk a little bit now about performance, especially when it comes to areas of configuring, monitoring, different capabilities of performance to make your application faster and keep it fast. And I really want to make sure that I also call out some of the new capabilities with Azure SQL. Now, a little bit like Anna talked about in availability, there are capabilities for performance for Azure SQL as compared to SQL Server. And there are tasks that you're going to perform to make your application fast, keep it tuned, and even troubleshoot performance problems. So let's kind of dive in to some of these areas. So from a capability perspective, it's really important to understand the capacities you have. You pick capacities today for a virtual machine or bare metal server, for SQL Server. Well, in Azure SQL, we give you different deployment options, whether it's choosing appropriate number of vCores for your application or the size of databases that you need. So for example, if you have a database greater than 8 terabytes, hyperscale is the choice you need to pick because we support up to 100 terabytes of database size for hyperscale. And so it's really important to make those deployment option choices both for Azure SQL Managed Instance and Azure SQL Database to support your workload. The good news is that in both cases, let's take vCore, for example, if you don't make that choice correctly up front, there are ways to automatically scale dynamically scale, in case of serverless, automatically scale those vCore choices without a database migration. So it's not like if you don't get it right the first time, you can't change it. You can make changes after you've configured. So for indexes, really important part of any performance of a SQL Server and in Azure SQL, you have all the indexes you need, whether it's non-clustered or clustered indexes, online, resumable, column store indexes. All of those index capabilities exist for your application and your database in Azure SQL. As far as in-memory OLTP, of course, a new functionality we introduced back in SQL 14 and 16 for low latency, high-speed transaction applications. That is available in Azure SQL, but only in the business critical tiers. And we're going to do things like pre-create the optimized file group for you, so you don't have to worry about those kind of things. And then as far as your memory limit goes for in-memory OLTP, it's going to be a subset of your overall memory limit for your Azure SQL deployment, a little bit like your SQL Server. Now, partitions, a very important capability people have used for years with SQL Server. You have support for partitions in both Managed Instance and Azure SQL Database, but you can only place partitions on file groups in Managed Instance. So SQL Server 2019 had many performance enhancements, and a lot of those kind of enhancements, like intelligent query processing, were born in the cloud. And so they exist in Azure SQL. Now, not every little thing we've done in SQL 19 that can add up to performance enhancements is available yet in Azure SQL, but we continue to look at those things like Tempdb optimized metadata, those kind of type features, and looking to include those in new releases in Azure SQL. So just an overview of the capabilities you get for a performance perspective. If you're looking at Azure SQL compared to SQL Server and wondering, do I have the capabilities I need? This is a great overview to see what is possible for you. Now, when you're going to configure for performance with a SQL Server, Tempdb is a very important part of that decision-making process that you do, whether it's the number of files, where do you put the files, and what we're going to do in Azure is we're going to abstract you from a lot of that. So we're going to put these files on SSD drives, so I/O performance is not a concern. And as far as the number of files go, we're going to auto-configure that for you, whether it's a database or a managed instance. In the case of database, we'll scale those files depending on how many vCores you support. And all the different options you need that you've used with trace flags before, those are on by default. But just remember that Tempdb metadata optimization is not available yet in Azure, but that's something we're certainly looking to in the future to put in. So the good news from a Tempdb perspective is there's very little for you to configure from a SQL Server perspective or a T-SQL perspective. You can make some adjustments, though, based on things like vCore choices. Now, as far as the database configuration goes, all the alter database options, alter database scope configuration options, just about everything you would need for performance exists with Azure SQL, both with managed instance and database. One option you might want to take a look at, though, that could affect performance is the recovery model. So in order to meet SLAs for availability, which Anna covered, we only support a full recovery model with Azure SQL. And that means that for bulk load import operations, you cannot do minimally logged operations. For kind of keep that in mind as you're doing these imports into Azure SQL. It is supported in Tempdb, so that's an option you could pick, or you could use clustered column store indexes, which can accelerate those import operations. Now, what about files and file groups? So one of the number one things to abstract you in Azure SQL, because it's a platform as a service, is physical placement of files. But if you think about it, who cares? I mean, we will decide where to put these files for you as far as your database and log files go, but we're promising you certain I/O performance and latency requirements depending on your choice of general purpose, business critical, or even vCore choices. So you tune your I/O based on your deployment choice, whereas we'll abstract and worry about where to put these files. Now, in some cases, the number of files in a managed instance and the size of files, in the case of like general purpose, is because we're putting these in Azure storage, they can affect your ability to get bigger I/O performance. And we document, though, the process for do that, because you can choose in managed instance the number of files you need for a database. We just don't allow you to put physical placement on those files. And then you do have the ability to do a file group for manageability purposes, and in some cases, performance purposes with managed instance. Now, what about max degree of parallelism? A very common configuration option that a lot of you choose for performance. Well, we have everything you need. All the different options you would pick in SQL Server for MaxDOP all exist with Azure SQL. And of course, managed instance supports resource governor, so you do get to put MaxDOP from a resource governor perspective as far as a user, a workload group, or a pool, and you get to do that with resource governor managed instance. And then we support these user-defined pools and groups with resource governor with the managed instance. We'll use this behind the scenes actually in Azure SQL Database to do resource limits, but you only in managed instance get the option to build your own resource governor workload groups and pools, because that's kind of like an instance level feature. Now, that's about configuration and that's about capabilities, but you always want to monitor and troubleshoot performance with SQL Server in many, many cases, and you're used to having a wide range of tools. Well, here's the good news. Just about everything you have in SQL Server, we've got you. We've got additional things though. You're running now in the Azure ecosystem with Azure SQL. So we're gonna snap in and integrate with Azure Monitor, Metrics, Alerting, and Logs to allow you to do things from the portal and from a command line interface to look at SQL Server performance information from Azure SQL integrated with the Azure ecosystem. Now, you're used to using DMVs and extended events. And again, the good news there is that we have all those capabilities you need, both for Azure SQL Managed Instance and Database. Now, lightweight query profiling, which is now on by default in SQL 19, is on by default in Azure SQL. So the ability to walk up to a live Azure SQL and look at actively running queries and see their progress in flight is a very important step in looking at a performance problem for a long-running query, and that exists and that capability in Azure SQL just like SQL Server. So you may be used to doing query plan debugging with things like set statistics IO or set statistics show plan or set show plan on. All those options exist with Azure SQL. All the integration pieces exist through Management Studio. You get to do those normal things of looking at plans with Azure SQL. And then Query Store, being a great functionality in SQL 16 that we introduced, that's on by default in Azure SQL. And I really recommend you leave that on because it's going to light up new capabilities, especially you're going to see later in this presentation on Azure SQL Database for something called automatic tuning. And in fact, by using Query Store, there are new performance visualizations in the Azure portal that take advantage of that rich Query Store execution information that is stored in your database. So as part of monitoring, dynamic management views are a very important part of monitoring a SQL Server, and you're going to love the fact that the capabilities exist in Azure SQL very similar to a SQL Server. And in a managed instance, all the DMVs you have in SQL are available, but there are new DMVs like server resource stats to give you overall resource usage of your managed instance because you don't have things like perfmon. For Azure SQL Database, it's not a full dedicated instance you can see behind the scene, even though we're using that. So you don't get all the DMVs from SQL Server, but all the common ones you're used to using, like DM exec requests, all exist. And the new DMVs, like DB resource stats, exist. Similar to a managed instance, this is going to give you overall resource usage for your Azure SQL Database from a CPU, IO, and memory perspective, and it comes in very handy for you to look at those things when you're monitoring performance. Now, there are some DMVs that you're used to using that are very important for you to have, like DMIO virtual file stats is really the only way to look at things like IO latencies for your SQL query performance. And so you're going to want to take a look at that one. OS performance counters, which has been around in SQL Server, it mimics what you see in Windows perfmon counters for SQL Server. And that DMV exists across Azure SQL for you to use as well. And then DM user DB resource governance is very important because it's going to allow you to take a look from a programmatic perspective at the configuration you've made from your deployment options. Like how many CPUs do I get? What's my memory limits? What's my IO rate limits and so forth? So you can look at those kind of things in the portal or you can look them up in the documentation, but it's kind of cool to have that available to you in a DMV. Now, I like to geek out. I don't know about you. These DMVs expose so much rich information. So there are some DMVs that we use behind the scenes to actually help monitor Azure SQL deployments for you and troubleshoot problems. And we expose some information along these lines. And you have an opportunity to go and look at some details behind how we do resource governance, for example, with some of these DMVs. So DMVs, rich part of the SQL history of monitoring, all available in Azure SQL. Now, if you're looking at performance problems, I like to look at things in terms of scenarios. So for me, from a SQL Server perspective, if you're looking at a problem with a query or set of queries, a query can either be running or waiting. So looking at your overall resource consumption usage by using either things in the portal or using these DMVs is important to find out, am I running, which is like a high CPU problem? And in fact, you can see the types of tools you would use, whether it's Query Store, DMVs, or looking at things like SOS Scheduler or yield weights to go look at a query performance problem to see, I've got a lot of CPU, what could be causing a bottleneck for my application? Or it could be that you're waiting on a resource. And here are some of the types and categories of commonly seen wait scenarios you can have for a waiting problem. So you're either running or waiting, and your ability to go solve that problem is dependent on taking a look at these scenarios. Now you're going to see in a demonstration in a second that CPU can be a very interesting problem where it is both a waiting problem and a running problem. We'll explain what we mean by that in a demonstration. So again, DMVs available at your disposal. You're used to using these in SQL Server. They're all available to you in Azure SQL. And again, I encourage you to take advantage of the query store. So break down performance problems in this way, and I think it'll make your life a lot easier. Now, there are some specific scenarios to Azure, and it's important to kind of cover those so you can recognize these and take action. So for example, in order to meet SLAs, we can throttle the amount of transaction logs that you generate in your deployments. Depending on your deployment choice, your service tier, your vCore choice, these rates will scale up. But these are some of the wait types you might see if you're being governed on log limits. And you need to go take a look at, do I need to be generating that much log, or do I need to go up to a new tier or new vCore in order to avoid this throttle? Now, worker limits are important in SQL Server, and I've seen applications sometimes run out of worker threads. A lot of times it's blocking problems, but if you run into worker limit problems, you might be exposed slightly different between a managed instance and Azure SQL database. So max worker threads are still applicable to managed instance, but we have specific concurrent worker limits that can result in an error in Azure SQL database. And we document what those limits are depending on your service tier and vCore choice. Now, business critical, as Anna described, is a very interesting availability architecture. And behind the scenes, it's deploying an always-on availability group. But I've seen customers deploy business critical and then be surprised that they'll see a wait type like header sync commit. They're like, well, I didn't deploy an availability group. I would normally only see that in those situations. But remember, we're doing that behind the scenes. So the point is that these are not new scenarios for business critical. They just may be unexpected wait types because you don't know that we're using an availability group behind the scenes. And then finally, hyperscale with that unique architecture brings some interesting problems and scenarios to it, depending on how we're scaling. So log throttling could look like something called an RBIO wait, because we're waiting on those cache scenarios in your architecture. And page servers have an impact on what you're doing in hyperscale from an I/O perspective. So we expose diagnostics in our DMV catalog views and extended events specifically towards the page server read type architecture. So those are some of the interesting specific scenarios to Azure that you may not see in a SQL server. Now, you might be in scenarios where you see a performance problem and you need to tune and accelerate performance. So first, it all starts with CPU capacity. If you had to do that on premises or in a virtual machine, you may have to actually deploy a new virtual machine. You may have to migrate your database somewhere else. You're going to find out it's very nice and easy in Azure SQL to scale your performance. In the case of serverless, we can actually do auto scaling. And then hyperscale is really nice because of the architecture we're doing, the scaling of that operation can be in very constant time regardless of the size of your database, which may not be the case in other service tier choices. So what about I/O performance? Well, first, it's kind of important to understand IOPS, what that even means, because if you're restricted on IOPS, it could show up in longer I/O waits. And your IOPS are dependent, again, on those service tier vCore choices. And in some case, with managed instance, it could be affected by your choice of the number of files or the size of files. So if you're running into I/O latency problems or IOPS restrictions, what you're going to have to do, you certainly should look at your application. But it may be that your application's tuned, you just need more capacity. And so choosing the appropriate number of vCores or moving up to, say, business critical or hyperscale could be important for you. And then when it comes to transaction log I/O latency, like write log waits, it could be that you're doing singleton transactions, and that's really not the best way for your application to be designed. So using multi-statement transactions could be a better design pattern and actually save you money when it comes to Azure SQL. And to increase memory or workers, we talked a little bit about worker limits. Those are based in Azure Database based on your vCore or service tier choices. In managed instance, it's based on max worker threads. And then memory is something that is very important in your application, and that is also based on your service tier and vCore choices. It's because we'll scale up the amount of memory you get depending on what that choice is. And then don't forget about application latency. You know, redirect connections are faster than using the proxy all the time. So that's an option you can pick when you're configuring your Azure SQL deployment. So take a look at that. We have good documentation on it. And then I have this concept called chatty applications. Avoid those scenarios where you're sending so much network traffic over, especially if your app is on premises going to Azure SQL. It could save you time and money and performance for your application with Azure SQL. And don't forget, this is a SQL Server. So tune your queries and tune your database with indexing, using batching, using server-side programming with stored procedures, parameterize queries, process those result sets correctly. All the best practices for a SQL Server still apply. Your skills in doing these best practices with SQL Server very much apply still in the cloud. Let's take a second and look at a demonstration how you might monitor a performance problem in Azure SQL and how we can actually scale it and make it run faster. Now I have a workload I'm going to kick off and show you to monitor its performance. This is a workload running queries against Azure SQL. I'm using the popular tool OStress to run like 10 concurrent users for this query over and over. I can come here with Management Studio and look at this DMV I mentioned, DMDB resource stats, to see what kind of CPU percentage is being chewed up. This is a general purpose 2 vCore Azure SQL database deployment. You can see here this is showing like almost 100% CPU utilization. I can look at DM exact request, again, one of the most popular DMVs in the world, and I can see I've got a lot of runnable queries with waiting on SOS schedule yield waits. That's a very interesting pattern for me to look at to see, do I have enough CPU capacity to run this workload? Now this query finished, and you can see here that the query took around 1:30 seconds to run. Now, that may not seem slow to you, but I think it could run faster. So I'm going to go look at Query Store and look at the top performing queries in my database. And you'll notice here, this is the query I'm running. And I can tell already by looking over here at the plan that the average duration for this query is something a little bit under 4 seconds, which that doesn't seem initially bad, but I'm running this a lot. Now, I saw those SOS schedule yield waits, so I suspect perhaps a problem with CPU capacity. I can look at query wait statistics and find out that sure enough, I'm waiting on CPU resources to run my query. And in fact, if I click on this, I can see for this query, the average wait time on CPU is almost the entire duration of the query. So how do we make this run faster? Well, go back over to Management Studio here, and I can see and find out through this DMV, what is the number of vCores I'm supported here and what service tier have I chosen. It's a general purpose 2 vCore limit. Maybe I just need more CPUs. I can use the power of T-SQL. I could use the portal, but I could go into T-SQL here and change with a single command here to now to scale up now to 8 vCores for my application. Now this is an asynchronous operation, so it'll take a few minutes to run, but this is going to give me more vCores for my deployment without me having to migrate my database. Now again, after like a minute or so, you can see by running this DMV again, I'm now up to those 8 vCores. Now, in order to see performance information, I'm going to flush the query store here to disk to make sure I get the right performance statistics to show you this comparison. And I'm going to go off and kick off this workload again. Again, it's just using the common OStress tool. Go back and take a look at your DMV information. Let's look at DM exec requests. And I can see now that I have more queries that are in the running state, not waiting on CPU resources, than in the runnable state. And if I also look at my other DMV for resource stats, I can see now a history, and notice here that's using less CPU percentage than it did before. So if you go back over here now, you can see this query is now completed in a much faster time just by scaling up to 8 CPUs, to 8 vCores. I'll go back, look at my query store reports again, and I'll notice here that in query store, I can see now that the average duration for this query is much faster. Notice here that the average duration is only like 1 millisecond. So what about waits? I'll look at query wait statistics, and I'll see here, I'm still waiting on CPU, but notice here that the overall average wait time is significantly less than it was before. So a great example of just showing you the capabilities of scaling in Azure SQL, getting faster performance with no migration of your database, simply by making a T-SQL change. Now, before I leave this demo, I wanted to show you an example in the Azure portal of that Azure metric integration I talked about. For my database, for my 8 now vCore database, you can see CPU utilization for the last hour I've been running. You can see this was when I had the 100% CPU utilization with 2 vCores, and now a lot less CPU utilization for a shorter period of time now that I've scaled it to 8 vCores. So Azure Metrics, Azure Monitor, we integrate Azure SQL resource information with Azure, allowing you to do things like looking at this information in the Azure portal. So kind of want to end this conversation on performance with new capabilities in Azure SQL called automatic tuning, specifically index recommendations. We're going to use machine learning algorithms to monitor your workload, not look at your data, but look at query performance over time. And you can see some screenshots here I have of what's possible. Looking at visualizations in the portal and giving you recommendations for indexes you should add to your workload. And if you like what you see from these recommendations, you can automate this. You can say, hey, Azure, do it for me automatically. Go ahead and create indexes needed at looking at my workload over time. And we don't just look at a single execution of query. We try to make sure using the power of query store and DMVs, we collect this data in a database, and we use machine learning to determine, is this really going to make this workload faster over time? If you're worried we make wrong decisions for these indexes or your application changes, we continue to monitor your workload, and if necessary, we can drop databases that we've drop indexes that we've previously created to ensure that your application runs its fastest. So check out automatic tuning with Azure SQL Database. Great functionality, comes with your subscription. You don't have to do anything special. We just do this automatically for you by deploying an Azure SQL database. Let's take a second to look a quick look at a demonstration of what I talked about with automatic tuning. Now you're looking at the Azure portal for a database I've deployed, and this is something called Query Performance Insight, one of those visualizations we're using in the Azure portal based on Query Store. So I can see performance of specific queries over time, or I can click here and look at recommendations. This is automatic tuning in action. We're either suggesting indexes to create, indexes to drop, and we'll show you the impact on those operations. And if you like our recommendations, you can automate these operations by declaratively choosing at the server level or database level whether you like indexes to be created automatically and or dropped automatically. Automatic tuning for indexes, using machine learning with Query Store and DMV telemetry to make your application run faster. Well, that's a wrap for performance. Whether choosing the right capacity for your performance needs, scaling up or down without database migration, Azure SQL has the capabilities you need. But we have the tools you need: DMVs, extended events, Query Store, powering things like insights in the portal and automatic tuning. And don't forget that we integrate with Azure ecosystem, including Azure Metrics, monitoring, logging, and alerts.
As we close out, we do want to share that we do have a ton of resources for you to get hands-on. Bob and I have mentioned we've been working on this for a while, so there's lots of things for you to go use and try out and actually use for yourself if you want to go teach this thing. We have content in GitHub, which you can see at SQL Workshops. This is going to include slides for our whole day of workshops, and we would love if you would take these slides, take our labs, and redeliver them to your friends, colleagues, customers, etc. In Microsoft Learn, we recently launched a whole learning path which includes free sandbox environments, which basically means you can do hands-on exercises with Azure SQL Database for free. Use the portal, use some of the command line tools, all of it for free, and learn a lot. That content was developed by Bob Ward and myself. Then, the documentation, whenever I can't remember something or I'm trying to learn something because there's so much to learn, I always do like a Bing or Google search and I type Azure SQL Docs, then the name of the problem I'm looking at, and that can be really useful. So don't forget about our documentation. Two other video things if you like videos because you're here. Azure SQL for Beginners is a 61 video series where Bob and I dive deep into all of the topics in the Azure SQL workshop. We kind of just scratched the surface here, so we definitely recommend you can go check that out on a topic-by-topic basis. Additionally, Data Exposed, I had to do a shameless plug. This is a show I host on YouTube and Channel 9 where we bring in various PMs and engineers from the Azure Data team to talk about what they're doing and kind of demystify some of the new stuff and show us demos and lots of fun stuff. We have new episodes on Tuesdays and Thursdays, so we hope that you'll check it out and that they'll be useful. With that, I want to thank you all for joining.
Yeah, I just want to say also thank you for joining today. SQL Bits is one of our favorite events in the world, and we're sorry we can't be there in person to present. But we hope today you learned a lot about performance and availability and how it's very similar to SQL Server, but with further capabilities in the cloud to help accelerate your business and your application. Azure SQL is the world's database, and we believe if you're a SQL Server person or new to SQL Server, it could become the platform for you to run your data workloads, especially when you need to make that migration to the cloud.